So this is section 3.2.3, which is multiplying and dividing rational expressions. So your class for today is going to be problems 85 through 88, and we're actually going to do the first two together, so hopefully you chose to watch this video. So with multiplying and dividing, this is actually the simpler operation compared to addition and subtraction, which we will do for the following lesson. So we are going to kind of go back to, well, how do we just multiply regular fractions before we get into multiplying these rational expressions? So we'll start with 85, and 85 is talking about review your work from yesterday by simplifying the rational expression at the right using a giant 1. And then we want to know what the excluded values are for x can be. So in other words, what can x not be? So when we do this, the first step is to factor both parts. And I'm going to, again, use that CPM method, which is the area model. So I'm putting my first term in the first box, the last term in the last box. And then I need two numbers that multiply to negative 12x squared because that's the product. But they have to add to 11x. So we're going to use 12x and negative x. And then I'm just going to come up with the dimensions. So 3x and x, 4, and this would be negative 1. So that means the top portion is going to be 3x minus 1 and x plus 4. And then we will do the bottom. So same thing. 2x squared is the first box, and then 12 is the last box. So we need a product that equals 24x squared, but we need them to add to 11x. So we're going to use 8x and 3x and fill those in. So this would have to be 2x and x and 4 and 3. So then our factors are 2x plus 3 and x plus 4. So now that we did that, using what we learned in the last section, if we have something, anything divided by itself is actually 1. So remember, we can kind of think of this as like 3x minus 1 over 2x plus 3 times x plus 4 over x plus 4. So by thinking of it like that, we know that this will actually reduce to 1. So then our final answer is just 3x minus 1 over 2x plus 3. So that is what it reduces to. But we have to say what our restrictions are. So excluded values, x cannot equal. So even though we reduced the x plus 4 over x plus 4, we still need to state it, because if that were negative 4, we wouldn't even be able to get to the point where we are. So x can't equal negative 4. And for the other one, it would be x can't equal negative 3/2. And I'm not showing that, but really quick, what we're actually doing is just setting it equal to 0, right? And seeing what would make it equal to 0. So in this case, it would be negative 3/2. So you really need to get in the habit of anytime we're working with rational expressions in this chapter, which is pretty much all of the sections, you have to state the restricted values. Okay, so that was 85. We're going to go ahead and look at 86. So for 86, it says, with your team, which is with me, we are going to review our responses to homework problem 82. So verify that everyone obtained the same answers and be prepared to share with the class. So let's just quickly look at, like, how do we multiply basic fractions? And I know for a lot of us, this is super simple, but some of us forget the basics. So we absolutely can multiply straight across, right? 2 times 9 is 18, and 3 times 4 is 12, and then we can just reduce that. Well, what do both 18 and 12 have in common? They have 6, so this would be 3, and then 12 divided by 6 would be 2. And did I write down the problem wrong? 2/3 times, yes, I did, times 9/14. That's why I was getting something different. Okay, so 2 times 9 again is 18. And then 3 times 14 would be 42. So if we divide by 6 for both, we get 3 and 7. So we can absolutely do it like that, but another way we could do it is actually to reduce before we multiply it out. And they're trying to get us to do that because it's going to make our lives easier when we're working with rational expressions. So instead of multiplying and getting this gigantic number, let's reduce before we get our answer. So in other words, I can take out a 2 from here and make that a 1 and make this a 7. And I can take out a 3 here and make that a 1 and make this a 3. And then look, our answer is already there. It's 3/7. So it makes life a little bit easier. So looking at the next one, we have 3/5 divided by 12 over 25. So you can really think of this as 3/5 times 25 over 12. So remember, when we are dividing, we're really multiplying by the reciprocal, and we're going to use that same technique with rational expressions. And then when we multiply, we can multiply straight across. So 3 times 25 is 75, and 5 times 12 is 60. And then we can divide both of those by 15, because that would be the greatest common factor. So this would be 5 and this would be 4. So our answers are here. But let's see if we can do that in a simpler way. So again, reduce before we get our answer. So looking at this, I could take out a 5 from here and make that 5. And I could take out a 3 from here and make that 4. So then our answer is 5/4. So in my opinion, it's actually a lot easier to reduce before than as opposed to multiplying and getting a giant number and reducing after. All right, so now we are going to look at problem 87. So it says, use your understanding of multiplying and dividing fractions to rewrite the expressions below, then look for giant ones and simplify. So giant ones are just where we can reduce it to 1. For each rational expression, also state any values of the variables that would make the denominator 0. Okay, so looking at A, we'll start this one together. So they actually made this easy because it's already factored out for us. So we will have ones on problem 88 where the first step you want to do is actually factor, so then you can cancel out the giant ones. So in this case, I see that the x minus 5s cancel. So our answer is just 4x plus 3 over x plus 3. And hopefully we all know that we can't just cancel out the 3 because we talked about that in the previous lesson. So after you get your answer, which is right there, that's it, very simple. You also want to state your excluded values. So x can't equal 5 or -3. So remember, even if it reduced, you still write it. You really should actually do that first before you solve it. So I'm going to go ahead and skip to problem E, just because it's a division problem. So the first step is, like I said before, I actually want to write out our excluded values. So we are looking at what really any variable can't be. So in this case, y can't be 0. So you want to look at both denominators, so this part and this part. And in both cases, y can't be 0. The next step is to rewrite this as multiplying by the reciprocal. So we would have 15x cubed over 3y multiplied by 4y squared over 10x squared y. Okay, so you also actually have to do the excluded values for your new denominator. So that's what's unique about division. You have your excluded values from the old denominator, the original one, and then for the new one as well. So we also want to state that x can't equal 0. And then from here, we're going to multiply. So I'm still going to kind of use my process of reducing before. So I'm going to change this to a 5 and this to a 1, right? Because 15 divided by 3 is just 5. then when you look at that, we could actually keep simplifying. So this would be a 5. We can just reduce that, and then this would become 2. And then we can cancel out the 2 and make that a 2. So I'm going to go ahead and just rewrite what we have here so it doesn't look super sloppy. So we have 2x cubed y squared, and on the bottom we have x squared, and then we have y times y, which is y squared. So this will allow us to cancel out those y squared because that's a giant 1. And then when we divide exponents that have the same base, we really subtract. So 3 minus 2 is just 1. So our final answer would be 2x, and then obviously you would state if x can't equal 0 and y can't equal 0. Okay, so after you complete this, the next step would be to do your problem 88, and just looking at that quickly, problem 88 is just more complicated ones. So you obviously finished 87, and then for 88, you'll notice that they are not factored. So instead of like multiplying, for example, looking at D, you don't want to just multiply 12x minus 18 times x squared minus x minus 12 and get this giant cubic polynomial. What I would recommend is factor first, and then state your excluded values, and then start canceling things out. So hopefully that will give you a great start to the lesson. So you'll just complete 87 and 88.